Hi, welcome to the video on the last two practice problems we're going to go over in this packet. So these problems that I'm going over now are from part 2, and we're going to start with problem 1. So first up, read the problem, and I want you to identify your given and find. I'll read it aloud for you and then give you a chance to identify your given and find. Thallium-208 has a half-life of 3.053 minutes. How long will it take for 120 grams to decay to 7.50 grams? So as you can see from the problem, the information that we're given the half-life. So I'll use lowercase HL for that. We're asked how long it will take. That's our elapsed time. So what we're trying to find is the elapsed time. And 120 grams is what we're starting with, so that's our initial amount, and our final amount is 7.5 grams. Okay, once we have our initial and after our given and find, the next thing we need to do is decide which equation are we going to start with first, which one we're going to use second. So A and B, which of these are we using first, which one second? Since we're asked to find the elapsed time, that means equation A we're going to use last. We're going to use that one second. So the first equation we're going to use is equation B. All right, and I know that I'm using, just once again, the elapsed time is found in equation A. You can see it there. It's part of equation A. It's not part of equation B. So that's why I know that this one will be the last equation I use. So let's just go ahead and start with equation B. Its final is equal to initial over 2 to the power of HLC. All right, so we always use, so the first equation we use, whether it's A or B, we always use that to find the half-life cycles. Okay, so that's because as you notice in both of these equations, it's there. So let's go ahead and plug in our information. Our initial is 120, so I'll plug that in into the top there. And our final is 7.5. I'll plug that in here. Okay, so now I'm going to use some math to solve. Whenever you have a fraction next to an equal sign, you can use inverse operations. And I'll use a different color and may make it easier to see this inverse operation work. I'm going to put this over 1 just to make it a fraction. Sometimes it makes inverse operation, not inverse operation, cross multiplication easier to see. So I'm going to cross multiply. Same thing I did in the previous video. Okay, so I'm going to get 7.5 times 2 to the power of HLC is equal to 1 times 120, which is just 120. All right, so now to further isolate my unknown, I'm going to divide both sides by 7.5. Trying to get that unknown by itself. And it can't be by itself in the denominator. That's why I have to get it out of the denominator using cross multiplication. Now some people think, oh, can't I just multiply the 7.5 and the 2 together? You can't do that because they're not like terms, and the reason why they're not like terms is because this value here, this 2, is a base of 2. 2 raised to whatever power has a base of 2. Whereas this one, this is the base is 7.5 raised to the power of 1. So because this has an exponent that's not 1, we can't multiply these out. All right, so when I divide 120 by 7.5, I get 16. So what I have now is 2 raised to the power of HLC is equal to 16. So I can solve for the power of HLC using mental math. Why don't you give that a go? So if you were using mental math, you would try and figure out how many times you multiply 2 by itself to get to 16, and the answer to that would be 4. 1, 2, 3, 4 times I multiply 2, and that will give me 16. So that means that HLC is equal to 4, and you could stop there. That's if your numbers are nice and neat. If they don't work quite that way, or if you're not sure about how to use them to do the mental math, you can always use logs. So this will be log base 2 of 16 is equal to HLC. Now if you have a fancy calculator where you can change the base, you can plug this in and then the calculator will give you the answer. But if you don't have a fancy calculator that changes the base, we're going to write this using a property of log. And I'll be using, my calculator has log base 10, so I'm going to solve this using the log base 10 function. And what I'll do is I'll take the log base 10 of 16, so that the big number here, what's called my argument, divided by log base 2, which is the small number. So log of the big number divided by log of the small number. You plug that into your calculator. It gives you the same value, 4. So that means my HLC is 4. Great. We're not done. Because remember, we're using equation B to solve for HLC, and now we'll use equation A to solve for our find. Okay, so what will it look like when we plug in all of our information into equation A? So in this case, we're given the HLC. In fact, I'm just going to rewrite the equation. We're given the number of half-life cycles, right? So that goes in for here. My elapsed time is my unknown, so that's my question mark. And then my half-life they gave me is 3.053. So when I rewrite this, I get 4 is equal to my unknown divided by 3.053. And then once again, if you have a fraction next to an equal sign, you can use the shortcut of cross multiplication. So I'll multiply these together, and then I'll multiply these together. All right, and it doesn't matter which side you put it. There is a convention, but hey. Okay. So we have 4 times 3.053 is equal to my elapsed time. And I get 12.212. And in honor of sig figs here, I will use 3 sig figs. Oh, and I can't forget my units. If the half-life is in minutes, then this will be, the elapsed time will be in minutes. All right, one more to look at. The next one we'll go over, it will be number